So let's just, let's start on the ICM motorized valves. And we won't move to the electronic controls until after lunch. How does that sound? Am I boring you guys? I hope not. I hope it's been, I mean, I always want these things to be something that, you know, everybody gets at least something out of it. That's my objective. I've only been doing these things for a couple of years. Because an application engineer typically spends a lot, you know, and I've been in other divisions of Danfoss, and I have to tell you, I've been a compressor guy, I've been a valve guy, a little bit controls. I don't want to brag on that because I'm not. You know, that's what you have to work with controls a lot to be a controls guy, and I recognize that, and I just know the basics, and I can troubleshoot a little bit. And then the other thing is that I'm an integrator. And have been, because I was a test engineer in my earlier life as a young guy out of college. And I went to Auburn, War Eagle. There's probably no War Eagles in here, but I have to put that plug in there.
But you have an office here in Springfield?
Nope.
No.
I travel all over the place.
Well,
I'm located in Tennessee. No, I'm located in Tennessee. I am an application engineer that's new for the industrial refrigeration group. They are a growing part of Danfoss, and they've not had an application engineer. They've got people on the phone, tech support people, but what I do that's different is about 90% of my time is spent out in the field, either helping startup or helping troubleshoot or training or sharing with people experiences, or just helping them so that they're prepared for, you know, whatever. It's just it's a thing that we're starting to do more and more of. So I was here in this area doing some troubleshooting, and the guys in industrial refrigeration, we took the opportunity to say, hey, this is a good time to do something that we, you know, we haven't done before. So that's what I'm doing. So I've been on the road all week, Arkansas and Missouri. And I ride a Harley Davidson. It's my passion. So I was actually here 4th of July, riding in your lovely southern Missouri Ozarks and the northern Missouri Arkansas Ozarks. And man, I'm telling you, I had a blast. It was fantastic. I think I put 3,000 miles on the motorcycle just here when I was here in the area 4 days. So did a lot of riding. Okay. I'm going to move on and talk about the motorized valve. And I'm always curious because the ICM valve is, I'm not going to say it's new, but it's unique in its application. It is a high-end valve, but it's very functional in a lot of ways. And I'm going to show you that. But I'm always curious to know if people are seeing these valves because they're not common. Is anybody in this room? Okay.
I have two.
Excellent. Okay. Okay. Excellent. Very good. So you know that there can be standalone, but they can also be in the ICF valve station. So that's where you've seen them, in the ICF valve station.
Standalone.
Okay. It is a motorized valve with what's called an ICAD motor actuator on top. The unique thing about this valve, and I have one here that I can show the module in the small size. It gets different when it gets up to the big, but I'll show this because it's kind of interesting. So there's the module that's the ICM valve, and it would typically fit in a standard welded body, okay, like that. But we also have a line of up to, I think, 2.5 inch, 3. I think it's 2.5 inch. We have a flanged body. And it's like, why? Okay, you told me you're going away from flange. Why are you doing this? Well, let's say you've got a situation where you've got a 1-inch valve, and okay, I'm not trying to knock competitors, but you've got a Hansen or a Parker RS, and it ain't working right. It's just totally, there's something wrong. And you want new technology in there, but you got a flanged connection on your body. You can buy this bolts right in with what you've got existing. Take the old body out with its functionality, put this in, and now you can come here with this. You can come here with this, with function modules, and you've just replaced your functionality with new technology. Now, there are some other challenges in that, so it's not like, boom, because you gotta consider control and how it's gonna operate. But this would be pretty straightforward because it's mechanical, but this would be a little harder because if the other valve is something else and the PLC is not controlling it, then you might have a challenge. But in general, it probably would work. You could do this, and then you get the actuator, which we'll talk more here, but this is the actuator that operates that valve. But just to show you this, that this is available up to a certain size, and it gives you the ability to get out of something and get into something new. And that's not covered here, but I like to bring that up and show it. I've forgotten actually where I have that in my presentation, but it doesn't matter. Okay, so it's magnetically coupled. The valve opening degree is always shown on the display of that ICAD. You can control the speed. You can have manual control of the valve. It has the flexibility to have digital and analog outputs to do something, do some feedback or some switch or alarm or whatever. It also has an uninterruptible power supply feature. So what it does is you've got a battery backup. I've seen several examples in critical operations where when they lose power, this valve will normally, without backup, this valve will stop right where it is. So if it's at 50% and you lose power, it's gonna sit right there at 50%. Let's say you want it to close. The only way to do that is the backup UPS. So you've got the backup UPS, then you program this thing to say, I got a backup UPS. When it loses power, with the battery backup, it's gonna drive the valve to where you tell it to go. It'll go closed if you tell it, it'll go full open if you tell it, or it'll go to a specific opening degree percentage if you tell it. So it's pretty versatile. It's a nice feature. It can be controlled by either voltage or current, so 0 to 20, 4 to 20, 0 to 10, 2 to 10, modulating control. So that's the analog input for that. I don't recommend it, but you can actually use this ICM valve as a solenoid valve. I don't know why you would want to do that. But you can actually give it a digital input, and you can close it, and then you can open it 100%. That's an expensive solenoid valve, but I mean, people may do that, so just so that you know that you can do it. And then there's the option for 2 digital inputs for what we call floating 3-point control. So one digital input's gonna open the valve, another digital input's gonna close the valve, and another third digital input is going to keep the valve at the position that it's at. So opening, and then freeze at that position, and then close, and then freeze that position or close all the way. I mean, you've got complete 0 to 100%, 3-point floating. That's the way I would use that valve other than modulating, and that's why I say that, because to me the solenoid on off doesn't make sense for this valve. It's a waste of that potential of that valve, but I've seen it done. Okay, so it can be made up of as many as 4 components. The small sizes are 3. The valve body is what we said earlier is part of our ICV valve family, welded, and then this is an ICV flange valve, part of the valve family, so it's unique, but it fits right in there. Depending on the size, you're gonna have a function module and a bonnet together, or you're gonna have a function module and a top cover separate. Again, it depends on the size. So when you get to the large size over here, 100, you're gonna have a huge function module. I mean, it's pretty heavy. And so you end up with 4 parts, a separate top cover. Your combinations here, you can see them right there, valve sizes. So we have 2 actuators. I'll go ahead and say the 600A, which is this one, and the 1200A, which is a little bit taller and bigger than this, not much, but a little bit. It just has a little bit more power to operate a bigger valve. You can see the breakdown here. So for ICM 20 through 32, it's the 600. For the 40 through the 150, it's the big actuator, the 1200. You might ask I'll go ahead and tell you what the A means. So A is the latest generation of our ICAD. It just means that's the second generation. So two things. They used to have the cable connectors were actually part of this, molded in. Now it's a connector on the cable, okay? So that's new. And then also the A put an optical encoder in here. So what the optical encoder does, we'll talk about it later, and I'll converse over them. But it synchronizes what the actuator is telling the valve to do, and what position the valve is actually at. So if I were to put a screwdriver in that thing when I'm operating that thing, okay, without the encoder, it's gonna think that it's closed when the actuator drives it closed, but it's really not closed because I've got a screwdriver in it. The one with the optical encoder is gonna know. When it stops, it's gonna know that the valve is not moving, it's not closing, and it's gonna stay at whatever percentage that it's in, okay? That's the optical encoder. It's really a nice feature that was added a couple of years ago. So here is the important part. Okay, so there's, remember we talked about the two sizes. The ICM 20 and the ICM 25 through 65 is a direct driven. So it's got a spindle on the piston, and the actuator moves that through magnetic coupling, which I'll get to here in a minute. And then the large one is actually a little bit more complicated with not a direct driven, but a kind of a coupled with a pilot and a main piston. And so it's a little different when you get to the larger than 65. So the magnetic coupling is made between the stem here on the valve and the actuator. So here's the third function of the multifunction tool. It's right there. So the valve is closed. And you would think to open a valve, you turn it counterclockwise. It's backwards because of the magnetic coupling here. So I'm going to turn clockwise, and the valve's going to open with the manual operator. That's the beauty of this. So if you're trying to troubleshoot or you're doing something, just remember that it's, again, in your brain, it's backwards. So I want to close the valve, I'm going to turn counterclockwise. Now the valve's closed. Okay? That's the functionality of the multifunction tool. So, how does the magnetic coupling work? Well, inside here are a set of magnets that are connected with a drive to the spindle, okay? And then, correspondingly, in the bottom of this are a set of rotating magnets that have a square drive to the motor drive in here connected, okay? These actually, you can see they spin, and I hear the motor armature turning, okay? So is this, and this is, by the way, haven't said it yet, but this is 24 volts DC power, okay? 24 volts DC. I think a lot of our stuff is 24 volts DC with the exception of our controllers, like our EKC and EKU, those are 24 volts AC. But this is DC, and unfortunately, it does happen. People put AC on it. It's not a good thing. It doesn't have a good ending, unfortunately. But as this motor is getting the signal to operate, that's spinning. You can see when you use this how strong the magnetics is. I'll pass it around. I'm just going to drop it, please.
How much is it?
A couple of $1,000s.
So how do you know the valve with the valve? I mean, you got the magnet in here. How do you like physically verify that this thing is? It's actually that one don't have an encoder in it, so it doesn't know.
Yeah, it does.
That one does?
Yeah, it's a 600A.
Okay.
600A. So it's standard now. We don't sell it. We don't sell it without the encoder. It knows it from the current and the resistance.
But on that, it knows how that's fit, and it doesn't know how that's fit, right? Cause that could, I mean, what happens if somebody goes and takes a manual thing and puts it halfway, puts it on there?
Because, okay, the way we get around that is, let's see where you're going. The way we get around that is, every time this thing powers up, it actually is gonna calibrate. So the valve is gonna go full open and full closed and seat itself, so it knows where it is at all
And if
times.
it doesn't seat itself, it doesn't know, that would, that the encoder would tell you that's, so you pull that off and then physically unback it out of that.
Yeah, an example is, let's say you're, working with it and you are taking the actuator off and then you operate this.
Okay.
The encoder is actually not gonna help you with that, but it is gonna calibrate, and then that's how it gets synced back up. So you can go around the encoder, if you put an effort into it, but the idea of the encoder is, if you have a blockage in the valve, it always knows where the valve is.
I was just thinking, what if, like, for the factory, somebody's old, puts it back together, it's halfway,
Yeah.
it won't self-calibrate like it says.
But when you power it up for the first time, it's gonna calibrate, so it actually really doesn't matter. You bring up a really good point that I'm gonna go ahead and talk about right here, and that is that this valve is set up and designed, any of these, any sizes, is for about 75% of capacity. So there's a 25% cushion in this, okay? So, let's say, and this is, I'm gonna show you something that you're gonna do that's not a good thing, okay? So, yeah, I need my operator there, thank you. So what I'm gonna do is, I'm working on this thing, and I'm gonna put the ICAD back on, but before I do that, I'm gonna use this to open the valve up 100%, okay? Now, I take that off, I put the actuator on. Now, if the valve is not going to close until it calibrates, does a calibration cycle. The reason is because it doesn't understand that 25% I've just added at the top end. So what I recommend to people when they're working on these valves, and you're taking the actuator off and putting it back on, if you don't think you're gonna run, if you think you're gonna leave power on, which is not generally done, so you're always almost gonna have a power back on calibration, but just to be safe, what I tell people is, take that valve and either close it or make it off somewhere. Just somewhere where it's not all the way open. Put the actuator back on, you're fine. Yeah, so it's just something to be aware of. It's almost like it's almost like the analogy of an expansion valve. You know, expansion valves typically are designed with, they always have 20, 25, 30% over capacity. It's kind of the same scenario. We designed this valve to have a built-in over capacity. The actuator is typically not going to drive it to that place. It's not going to need to. But it's just something to be aware of.
Well, I mean, literally unplugging the red plug and plugging it back in, it'll go 0 to 100.
Yeah,
in
it will.
7 minutes.
It will. And another point is
You
that,
wanted to try
Can I
that?
see that, Patrick?
yeah, so this,
Yeah, this in a little thing, I just want.
yeah. So,
Might not see Thank you.
you can actually turn the encoder off. There's a parameter in there, you can turn the encoder off. But when you reset, you do a factory reset on these things. The way you do that is that you have the power removed from the ICAD, and you press the up and down arrows together, and then put power back on, and you see CA and A1 flashing. It's reset, so it's going to go back with encoder enabled. Or if you reprogram it, it's going to put the encoder back on. We don't recommend that you turn the encoder off, and that's the reason we do it that way. So you're going to physically have to turn that encoder off when you've got it set up and running, ready to run, and then it will be off. But I've never seen a situation where you would actually want that. I can't even imagine it. Okay, so here's the 100 to 150. Now this gets a little bit more, and I don't have an example because they're so big, but it operates a little bit differently. So the ICAD is at 0%, so the pilot piston and the main piston are coupled together with a spring. You can see that the brown there, it's real light, you may not be able to see it. So mechanically they're connected, but what's gonna happen is, when you go to open this valve, ICM starts to open, okay, so we're telling it to open. The spindle is gonna bring the auxiliary piston up, okay? And it's gonna equalize the pressure on the top of that piston, so the inlet pressure is gonna have a tendency to assist, so the main piston is going to follow. That's the way that you get the lift of the large valve, okay? The reason for that is just physically the size of it. It needs a differential, like most, we talk about the larger solenoid valves. It needs some differential to get them to open. So this is actually no different, and that's the way it works, and that's why it's not considered a direct operating valve. But it is similar. It's just not the same exactly. Here is the valve is open now. It's all the way open. You can see this is that's a cut cross section of the main piston. You can sort of visualize that. Okay, and then just an overview. We didn't talk about, like in our regulator valves, we have different cones. We didn't talk about this, but ICM is no different. We have a bunch of cones. We've got A, we've got B, we've got C, we've got A33, we've got B66. Just to not confuse you, but just to let you know, the A's typically are for expansion applications where you're wanting to expand or flash gas. And the B and the C are typically, I mean, you can, if it's a large application, you could use it for expansion, but it's typically going to be flow control, like for a large flow into a tank or something. That's just generally what we see. Just want to say that to keep that in mind. Let's see, what else do we need to cover here? Oh, and so what does that mean? Well, A would be the smallest. A33 would be 33% more capacity than the A. The B66 would be 66% more capacity than the B, and the C is just the largest. I see the C in some really big applications. There was a job I saw where they're using the ICM 125. Oh gosh, these things are huge. For suction regulators. I mean, it's just unbelievable to see this. Of course, they're running about minus 45 degrees temperature in the suction, so the valve's covered with ice. You can't even see it. So I bring that as a segue into what I want to talk about now. And in order to talk about it, I'm going to have to collect my parts back again. So let me see if I can get those back here real quick. Sorry. And that, and what else am I missing?
You ran it back up there.
You ran it back up there, okay. Yeah. So, here comes the food, so I'm going to try to make this fast. So putting this thing together, moisture is an enemy to this valve. This is magnetically coupled, so if you think about it, moisture in any case is not good. Now, moisture in a high temperature environment, and when I say high temperature, I mean above 0 degrees, so it's probably not going to affect it, most likely. But when this gets installed, it comes with this packet here. There's some set screws, 3 set screws in this, the collar. And you'll see there's a seal and then an O-ring. And below the O-ring, there's a groove. Okay, that's where those set screws are supposed to seat in that groove. That's important to note. Keep that in the back of your mind where that is. The O-ring is to keep moisture out. So what we recommend is that grease. It's a Molykote 4500. It's imperative that you use that. What you want to do is coat on here, and I think I have a slide. I may be getting ahead of myself. Yeah, I'm getting ahead of myself. So let me get back on track here. Okay, so the small valve, I'll go back to that. Sorry. I want to show that the small valve actually has a separate seat. This is just to let you know at a peak seat. That has to be removed when you install that valve. So if you rebuild this valve, the small ICM 20, it's going to have that seat. You're going to have to put it in. Installation, we've talked about removing the function module with a screwdriver. Installing, okay, the large valve. Talking about welding, which you guys typically are not going to be faced with. You can put, here it is, refrigerant oil on the O-rings. It's what we always say, it's what we talk about. And then here we go. So this is where we are. So it's got to be dry and free of debris. Okay, so we're going to put the grease on. What I typically say to do first, since you got the valve, so I'm going to put a generous amount of grease on that O-ring, just right there. You don't have to put it all over this thing, but all over the O-ring right there, just a generous coat. You can see it in the picture, it's pretty generous. And then the magnet coupling you can see in there, I'm going to put grease inside there between the segments, the magnetic segments and the gaps. Just coat it in there, don't be afraid, just be generous. Okay, and then once you do that, you install the ICAD down on the stem, and it will suck it down on there. But a lot of people make the mistake, they think, okay, that's where I want it, that's where I need it. Nope. Push down. Can't see it here. Boom. I push down on it, it kind of springs down over that O-ring. So when you push down on it, now those set screws, it's not installed, so I'm not able to do this. So you gotta push down on it, and you'll look and see, if I don't push down on it, those set screws are not gonna go into that groove. They're gonna go just above it. And what do you think they're gonna do if you don't push it down on there? It's gonna put a hole in your O-ring. Yeah, you're done. You gotta get an O-ring. So just push it down, and then tighten the 3 set screws evenly.
Would it operate if you didn't get it down all the way?
Yeah, it probably would,
'Cause
in most cases, but
I
in
had
a
one
low
fried.
temp application, I'd be willing to bet it's not gonna work forever. Because
Okay.
ice is gonna form in there, moisture's gonna get in there, and then it's all over the
I had one that was fried and I ordered it and then it got installed on my day off, so when I get back to the plant, I'm gonna go check it out.
Okay. Yeah, it's really important, you'll feel it, it's that seal, that O-ring that's springing down on it. It's not a lot, but it's just enough, so you push it down and then you evenly tighten the set screws. The reason for that is because there is a little clearance in there, and let's say I tighten up one set screw by itself, and then I tighten the other 2, it's gonna be off to the side. You want it centered.
Right.
Yeah, a lot of people will argue with that and say, that doesn't matter. And I'm like, you know what? Maybe it doesn't in 99% of the cases. What about that 1%? Where it's in a low temperature application and you didn't put the grease in right and you didn't push it down. Yeah, I get calls all the time about this thing's not working, and I'm just like, these things almost never not work. So you just stop and go, okay, did you follow the installation instructions to the tip? Did you know? And a lot of times I get it, guys are in a hurry to, but the bottom line is there's reasons for a lot of stuff that we have people do, and it's hard, I know, but in this particular case, it's extremely important to follow this. So, what else about this? Let's see here. Yeah, if the O-ring gets damaged, it's imperative that you replace it. Okay. So the heat is the first generation ice wouldn't melt. There was a heater there. We've taken the heater away. The motor heat is actually what keeps the bottom part there. So that's different. The cable connector's changed. We do have a protective cap for outside use, an optional cap that goes on top of this. I don't have one, but and now the cables are removable, which is it's really nice for troubleshooting, and maybe you want a calibration to occur. So you're on the roof and you're like, okay, I'll just pull this loose and put it back on, and away we go. And it will keep its configuration. Okay, but If you were to do this, hold the up and down arrow down and then remove that and then put it back on the, you just reset it to factory defaults and now you gotta start all over again programming it. The way you can tell that is if you did a factory reset, it's most likely it's gonna flash CA and A1 alternately, because what A1 is telling you is, the ICAD motor is telling you, hey, I don't know what I am. I don't know what I am. You gotta program me. I know I'm an ICM valve, but I don't know what size, because you're telling it like it's a 25. There's different numbers in the parameter setup. The other thing is if it doesn't reset, then it will be flashing, it could be flashing A1 and, CA and A3. CA meaning it's doing the calibration because you just turn the power off and turn it back on. And A3 because it's configured, but it's not got an input signal, 4 to 20, it's not got a proper input signal. Now, if it does have a proper input signal, then it's just gonna flash CA and then it's gonna go to the normal screen eventually. Does that make sense?
Yes.
Yeah. Okay. We'll get to, I think I'm gonna go ahead and try to finish this, just to be, because we're, get this done. So here's the original offering. We did have a 900, we don't have that anymore now, so like I said, the 600 is for the 20, 25, and 32. The 40 through 150 is now the 1200. We've standardized on that. The encoder is now there for position feedback. The rest of that is not anything that you need to know. One of the things there is nice to know, intelligent force compensation function, that's new. So it increases the torque when it's needed to keep up with lost steps. That was added as well. We're not going to go over the color coding. I mean, everything comes with about when you install it. The power, the UPS is black, the white and the brown for power, 24 volts DC. And then you've got all kinds of different colors for your digitals and your analog. A PLC would be a simple arrangement here for how you would drive with 4 to 20 from a PLC. It tells you that there. Then you've got your one digital input for solenoid, and it tells you the colors there. And you have a relay to, actually for open, full open, and then to close, you break that. And then your floating 3-point, you can see there that we've basically got digital inputs, 2 digital inputs that are in different orders to create a drive open, and then to maintain, or then to drive close. You can use this valve with our several different controllers. We'll get into that a little bit later, so we're not going to spend any time on that. We've pretty much gone over the principles of operation. Let me just peruse this to make sure I haven't forgotten anything. We talked about the manual opening it and losing its place. The motor will drive itself to a closed position to reestablish its reference. Okay. In the manual mode, the ICAD you can override put in manual. So what will happen in manual? The display will flash, and then your up and down arrow will take it manually open, manually close, but the display will continue to flash the opening tree. That's how the manual works. And when you put it in manual mode through the parameters, it's going to stay there until you take it out. Kind of a nice feature for troubleshooting. Let's say you want to troubleshoot something. I've done that actually a lot, where I want to go to a certain position and see what happens. The one that comes to mind was a big DX system where I couldn't get the thing to control at all. And so it was a big coil with a special type of heat pipe. And so I put it in manual and I said, okay, this thing's got a venturi, like an orifice. The ICM valve, all it's doing is feeding liquid to the orifice for the coil, almost like a fixed orifice kind of application. So I'm thinking to myself, okay, we're looking at superheat leaving the coil, trying to control that. It's just like all over the place. So I put it on a fixed position. I just said, okay, I'm gonna put it at 30%, and I'm gonna let it sit there for an hour and a half. And I did, and it never stopped. It just was like all over the place. I'm like, holy cow. And what it ended up being was that heat pipe. So you got the DX coil with standard evaporation through the coil, and then you got these static heat pipes on the front and the back of the coil that are closed. And they're charged with R134A, and you've got a heat exchange going on that's separate from the heat exchange in the main coil. So, I mean, heat exchange is heat exchange. So this thing's out here trying to control, with superheat, and then there's a second action going on. So the valve actually helped me, putting it in manual helped me figure out that, hey, there's no way this thing's gonna control like you think it's gonna control. So what we ended up doing, everybody agreed, yeah, this is the best we're gonna get with these heat pipes on here, so it is what it is. And if you want the heat pipes, you're gonna have to live with a little bit of superheat swing. And so it was swinging about 10 degrees, and we couldn't get it to stop. It wouldn't do it. So that's where, doing manual you think about it, it kind of helps sometimes. Okay, so we talk about the CA flashing, that's just telling you calibration. Okay, there's a new current version that in the display you're gonna see a CS every time the valve closes, only when it closes, and if it's out of the parameter mode. If you see CS, it just means the valve is calibrating its closure. That's all it means, and it won't do it very long. And we talked about the last item there, that 100%, don't open it to 100% and put the actuator back on. This is just good to know stuff. So the small valve, time to open and close 3 seconds, so it's very small, 1 1/4 turns. You can sort of tell that by this one when you're playing with it. When you get to the big 6-inch, look at that, 47 seconds from full open to close, and it turns 18 1/4 turns. So big dude. So just good information to know. Electrical data, we've already kind of gone over some of this. Temperature range, -22 to 122. We talked about analog voltage or current. The digitals, you can see the currents there, it's pretty small. 1.2 and about 2 to 3 for the 1200. And then 24 volts power. That needs to be between 14 and, I think it's between 14 and 30. And there's a way to check, you just need to make sure you check the voltage, because this thing is, I've actually tried it at home. I'm sorry, I said 14, 20, that's a different, this would be 18 to 30, I think. Whatever plus 10%, minus 15% is, whatever it is. So 24, I think it's 18 to 30. And I've actually tried it at home, with a regulated power supply, 18 volts, and you go below 18 volts, the thing won't work. It won't work right. So just something to keep in mind when you're troubleshooting if you're having problems. So we'll kind of cover this real quick here, because if you've used these, then you may already know, but just real simply here, you want to get into the programming. You press and hold the middle button for a couple of seconds till the menu screen appears, and you'll see that. You hold it down, it comes up. It shows like a J, or it looks like an I with a little curly in it, it's a J. And it'll be J01. Okay, so you go to J02 by going up arrow, down arrow, you go through the other list. So you just go through the list with the up and down. If you want to know what that parameter is set to, stop at it. So let's just say, for example, 01. I press the center button briefly, just briefly, and it tells me what it is. Okay, so it's set to 1. I want it to be 2. So I use my up and down arrows to put it on 2, press the center button again, and save it. That's that simple. So press it to see what it is when you're in the list, change it, and then press it again to save it. And that's what it kind of says there. The other thing was to reset. We said that was the up and down arrow with power, put it back on. Okay? And then to exit, it'll exit by itself, or you can press and hold the center button, it'll take it out immediately. And there's a lot of parameters, but there's only a few that are really important. We'll touch on, okay, so Opening degree is displayed all the time, so the main switch is the first one, so normal operation or manual operation. So that's where you put it in manual. The mode, modulating or on, off, or floating, so we talked about that. You can set your analog input on 3, the speed on 4, automatic calibration on 5, output signals on 6, it can be programmable. Fail-safe you're telling the valve what to do in 7, and 8 you're telling it that you have a battery backup. It's that simple. Digital functions are on 9. Sorry about that, guys. Password was 10, and that's for configuration. The rest of that you don't need to know. It's closing speed, manual set point. So that's saying when I put it in manual, where do I want it to start? Well, typically that's defaulted to 0. But let's say I put it in manual and I want it to go to 50%. Well, you could do that. Put 50% in I-15, and the minute I go to IO2 and put it in manual, it's gonna run to 50%. And then my up and down is gonna take it from there, but it's always gonna start manual mode at that percentage. Here's where you turn your encoder on and off, and your configuration of your valve. That's at 26. So here's the list. You tell it what valve what valve it is. Service troubleshooting parameters. That's 50 through 59. It's pretty useful. So let's say that I've got a problem with my analog input signal. The guy says, okay, I'm giving you an analog input signal, and so all I got to do is go to parameters, go to I-51, and I say 0 milliamps. Sorry, you may be sending it, but it ain't getting here. So that's the kind of thing you can do with this, and you can see all the things that you can look at and get status of. Doesn't do anything. It just displays for service troubleshooting. And here's the alarms. So I'll go over real quick. We already talked about A1. Nothing's been set up. A2 is really rare. If this happens, turn off the power, turn it back on. If it still doesn't work, you're going to have to return the actuator. It's an electronic thing. A3 just means it's confused about what you're sending it on the analog input. It doesn't like it. If it's not between 0 and 10 because that's what you told it, volts, or 4 to 20 milliamps, it's not that. It's going to flash A3. A4 is power. A5 is low voltage. A6 is calibration failed. I've never seen that one. A8 I've never seen. This thermal overload, so the motor overloaded because you thermal ain't got too hot. A9 is a common one that we see. It means the valve's locked up. And I've seen it on low temperature applications where they didn't install it correctly. Ice got up in the magnet and froze, and it stopped working. It locked the magnetic coupling. And that's not necessarily the valve, that's just the actuator saying, hey, I can't move. This isn't working. And it goes A9 immediately. Well, not immediately, 15 seconds. I think it's 15 seconds and it hits it. Troubleshooting, I don't know, it's everything I've covered. So is it mounted right? Is the O-ring, is the grease in there? Do the cones match? Is it really what I'm saying it is? Are you sending the proper control signal? So on and so forth. Things we talked about, voltage. Those are the things that can go wrong. Multifunction.